Good afternoon, everyone. I am Noriko Kishimoto at PICE, a foundation of river and basin integrated communication in Japan. So thank you for giving me the opportunity to make a presentation today. So today I would like to talk about the transdisciplinary approach in developing an IDR4M, which is integrated water-related disaster information system for municipalities. So IDR4M is developed in collaboration between a researcher and municipality. So, and my organization, FLIX, is one of our research members. So today I would like to talk in focusing on the collaboration with municipalities. So first, quickly, I will explain the outline of IDR4M using the 3 pages of slide. And so in Japan, municipalities are at the forefront of a disaster response and need to deal with many disaster response operations. So, however, many municipalities are facing these difficulties, like limited officials and lack of experience for disaster response, and huge amount of disaster-related information to check in a short amount of time. And also, there are no clear evaluation criteria like degree of hazard and so on. So in Japan, municipal officers moves to different sections in just a few years. So because of this quick job rotation, most officers do not have enough experience. So we researcher can't change this government rotation system, but we can help municipalities with science or offering the appropriate data. So we developed IDR4M. So IDR4M aims to provide disaster risk information to municipalities for science-based decision-making in disaster response operations, such as issuing evacuation order. Next, development framework. The IDR4M was developed in the cross-ministerial strategic innovation promotion program. We call this SIP. SIP is financed by the Japanese government, and it is also developed under the theme of enhancement of societal resiliency against natural disasters. And this figure shows the whole structure of the theme, this is the enhancement of societal resiliency against natural disaster. And under this theme, there are 8 sub-projects was conducted. And IDR4M was one of the 8 sub-projects. And it's number 7. Next, outline of the system. The development target of the system are these 3. Integrate disaster information and deliver them to municipalities in an usable manner, and develop an integrated hazards and vulnerabilities risk information system, and provide real-time and pinpoint risk information to residents. So also the IDR4M consists of 3 evaluation systems. The one is the hazards, the red one, hazard evaluation, and the second, the vulnerability evaluation, the green one, and the third is risk evaluation, the blue one. And ordinary disaster information systems are based on solely on hazard information. However, IDR4M's integrated risk information combines hazards and vulnerabilities. IDR4M can display both integrated risk and hazard information in one display. So municipal officers can use whichever most convenient information to make decisions on issuing evacuation orders. So this is about 18 model municipalities. Because IDR4M will be used by municipal officers and mayors in practical disaster operations, the system should be useful and easy to use for them. So therefore, while developing the IDR4M, we asked 18 municipalities plotted in this slide to participate in this research and development. So this is for municipalities to verify its usefulness and to identify points to improve during the development phase. Like, so we selected 18 municipalities from whole Japan in terms of different topography and characteristics, like urban area and countryside and so on. We wanted to have variety types of model municipalities. So, and we conducted demonstration experiment in the model municipalities, such as training and sometimes actual disaster response. So, consequently, 54 items to improve were identified, and 45 of them were reflected in the IDR4M. For example, there is a request from some municipalities, which is please extend hazard forecast from 6 hours to 12 hours. So at the beginning, we set the 6 hours forecast because 12 hours forecast is quite uncertain. So why a municipality request this is because they do not like to issue the evacuation order at night. So it's dangerous, of course, to evacuate at night when disaster happening. So, but if they know the risk 12 hours in advance, they can issue the evacuation order in daytime. So in the end, we decided to offer 12 hours forecast data with caution of the uncertainty. So, yes. And IDR4M has been used 19 times in actual disaster situation from 2021 to 2022 and has demonstrated its usefulness for decision making for issuing evacuation orders. And left side is the list of actual use. So, and right side figure shows the usage example. This is the screenshot of Katori City on the, it is the one of the model municipality, and they affected typhoon number 8 on August 8, 2021. In this figure, a blue box, two blue box shows actual warning issued. PM 136. Heavy rain warning was issued from meteorological agency, and the municipality issued evacuation of elderly at 250. Yes, 250. The lead time was just 1 hour and 10 minutes. So during this quite short time, municipality needed to prepare the evacuation shelter or the announcement. So let us check IDR4M at 9:10 a.m. It was 4 hours before the warning. IDR4M showed the risk forecast already. So 1:40 p.m., which is almost same timing with warning, IDR4M shows the prediction of higher risk in wider area will come. So municipality officer could have the enough lead time to issue the evacuation order using this IDR4M system. So typically in scientific and technological development processes, experiences of practitioners are rarely incorporated. But here in IDR4M development, practitioners, namely municipal officers, provided their extensive knowledge and experience they acquired through actual disaster operations, and it led to practical improvement of IDR4M. So thus we succeeded in developing a system that would actually work more effectively in reality. So thank you.
Katsuhama, floor is yours.
Yeah, thank you very much, Tenchi-san. Yeah, my name is Katsuhama from Nippon Koei. Yeah, Nippon Koei is Japanese consulting engineering company, and I belong to Digital Business Development Office of Nippon Koei. So today I'd like to introduce some other example of TDA, transdisciplinary approach. I want to introduce about collaboration between government and the private sector for the digital transformation of disaster risk reduction. Yeah, this is my theme today. And this is the contents of presentation. Number one is disaster events and the characteristics of disasters in Japan. Let me introduce about some brief explanation, of Japanese disaster situation. And number two is activities of Digital Authority Japan. Japanese government established digital agencies several years ago. So I want to introduce about it. And with this digital authority, we are doing some collaboration with private sectors about, we established a digital transformation committee in disaster risk reduction. So I will introduce about it. Then I will show you some examples of digital solutions provided by our company. This is the contents of my presentation. Number one is disaster events. So actually, Japan is called as the department store of disasters, but it's a situation similar to in Taiwan or the Philippines or many other countries in Asia. So this is earthquake occurred in Kumamoto Prefecture, western part of Japan in 2016. This is also one example. We have many floodings almost every year, and the situation is getting severe now. And we do have many volcanoes, like in the Philippines. Taiwan has only 3 active volcanoes, but Japan has more than 100 active volcanoes, like in the Philippines. Yeah. So for example, in 2014, more than 50 people were killed by vapor explosion of the volcano, in middle part of Japan. Now, after 10 years, we resumed. It was prohibited to climb the mountain after that, but this year we can climb the mountain again after construction of some evacuation shelters. This is also debris flow. Yeah, we experience many debris flow or some water-related disasters every year. And we do have a snow disaster also. This could not be happening in Taiwan or in the Philippines. Yeah, but snow disaster is also getting severer every year probably this is because of climate change. So the contents of vapor in the air is increasing, and we have more snowfalls recently. So this is a trend of a number of deaths and missing persons caused by natural disaster in Japan after World War II. So from after 1945. So this area shows because of the devastation of by the war, we had many casualties after the war, but after construction of some facilities to prevent disaster, it was getting decreased. But in 1995, we experienced the Kobe earthquake, a so-called Kobe earthquake, and more than 6,000 people were killed by the earthquake. And again, in 2011, yeah, probably you may know, so the Great East Japan earthquakes caused more than 20,000 casualties, yeah, in Japan. Even after it, every year we have many deaths or missing people by water-related disaster or other disasters. This is the situation in Japan because of some concentration of population to urban areas, and some places are becoming more vulnerable than before. Yeah, this is the present situation in Japan. And this is annual number of events with precipitation more than 50 millimeter per hour. So because of climate change, rainfall intensity is increasing compared to before. So we have more disasters compared to before. Yeah, the oscillation of rainfall is more than before. So now let me introduce about activities of digital authority in Japan. So the authority was established in September 2021. Taiwan also has the same kind of authority. I forgot the name. Shu-Tzu Fa-Chan Pu. Shu-Wei Fa-Chan Pu. And it was established September 2021. And it's, how can I say, across the disciplines. So the agency, the authority connect various ministries to develop some, to promote digitization and also to digitalization. So, and the character of the agency is 1/3 of officials are from private sector. Yeah. So they collect officials from various ministries, and also they invite people from private sector. Yeah, so this is the character of the agency. So they are aiming at the digitalization, not only digitization. So their goal is digital transformation. And the right side is website of digital agency, and they are trying to promote so-called My Number card. This is individual identity card, and they try to disseminate to all people in Japan, all citizens in Japan, to make some governmental job efficiently or to improve the quality of services. And this character is very, very small, but they have some matrix style organization, and they especially have some one offices relating to disaster risk management. So disaster risk management is one of the important tasks of this digital agency. So this is the character of digital agency. And actually, this digital agency requested our private sectors to form a committee to support the activities of digital agency. This is a so-called Public-Private Digital Transformation Committee in disaster risk reduction. So this committee is especially for disaster risk reduction. Let me introduce about the activities of the committee. So there is a website, a Public-Private Digital Transformation Committee on disaster risk reduction. And the purpose of the committee is to realize disaster risk reduction, both in usual and emergency situation by public-private collaboration. And members are actually many members. So now, as of August, last month, 357 entities consisting of 84 local public entities. It includes prefecture government and municipalities and public organizations, and 273 private entities, including Nippon Koei, my company, data providers. They are consisting of data providers or consultants or transportation or startups or SIRs or insurance or finance companies or media or medical or NPO and so on. So it covers various sectors. So it is also one of the transdisciplinary approach. So mission of the committee is we have three missions. One is clarification of issues. This is to clarify issues relevant to DRR to decide direction of public-private collaboration. This is number one. And number two is platform development. So this is also very important task of the committee. So we are going to propose ideal data linkage platform, especially from the viewpoint of platform users, such as citizens and municipalities. So we need to consider, or we need to do transdisciplinary approach to achieve the goals. And number three is market development. So to encourage private sectors, market development is very, very important. So this is to create new business opportunities, to realize digital transformation of disaster risk reduction by public-private collaboration. So this is also big purpose of the committee. And major activities of committees consisting of these 7 items. Number one is interview and questionnaire surveys to entities relevant to disaster risk reduction to identify issues. So we want to know the actual issues, so real cause of issues. And number two is identification of technological trends to determine areas of emphasis and accelerate dissemination of DRR solutions. And number three is design of data architecture and data linkage platform. And number four is design of data items for DRR applications. And number five, design of procurement criteria for applications and systems. And number six is design of usage of my number card, which I mentioned before, for disaster risk reduction. And number seven is other subjects to accelerate digital transformation on DRR. These are activities of this committee. Yeah. So let me, and this committee opens some catalogs of many private companies, including Nippon Koei, to show or to introduce municipalities or private sectors, about the solutions provided by private sectors. So the one I'm going to introduce is also included in the catalog. So this is some example. So I know in another room, there is a session for climate change. But this is a tool provided by Nippon Koei. So to know, this is to obtain future climate forecast information on rainfall, temperature, and so on for major cities. This is provided for free of charge. So if you access to this site, and you can know various case studies of future climate change, and you can use that data for some to plan adaptation measures or mitigation measures of climate change. So, and many domestic, Japanese and international agencies are using this system. So this is free, please check the website. And now we are, how can I say, increasing the usage of satellite image data. Also, this is some examples of usage of satellite image. So we have some collaboration work of satellite image providing companies, and then we get the data and to know if we use so-called SAR, right, we can know the surface of water. So we can check the actual inundation situation even immediately after the some water-related disasters. And also we can use this kind of satellite image by image analysis of For example, we can know landslide situation or movement of the ground from the satellite image. So now this kind of application is increasing in Japan. And let me introduce about disaster prevention information platform. We call it BOSCE. And we are developing this kind of disaster prevention information platform. It includes all kinds of disaster like earthquake or tsunami or water disaster or landslide in one platform by cloud basis. So we provide this kind of platform to municipalities or private companies for decision making. So we can do some, for example, real-time water level forecast by this platform. Now we are trying to apply this system to Davao City in the Philippines and also some cities in Japan. Yeah, this is a disaster prevention information platform. So this is a system concept of the platform, cloud-based one-stop solution for providing flood risk information or other information also. And the system provides prediction of water level rising, flow volume, overflow to floodplain by inundation analysis in real time. And the analysis can be customized. And we can add various add-ons. Oh, sorry. Yeah, like we can add some flood detection sensor or some satellite image analysis, which I mentioned. Yeah, and we can use it for evacuation simulation also. So these tools can support decision making of policymakers or some private company owners. Yeah. So this is the end of my presentation. Thank you very much.
The application in Japan. I'm very happy to see that it's actually working. That I think that is the most important for in disaster risk management. So our next speaker is from Taiwan, Dr. Chung-Ray. He's from the Slopeland and Hydrology Division of the National Science and Technology Center for Disaster Reduction in Taiwan. And the NCDR is the head of the in the disaster management and making a lot of important policies, introduce a lot of important techniques in the disaster, all kinds of disaster management in Taiwan. And Dr. Chu today will share his experience in slope disaster, different type of technologies in Taiwan. Dr. Chu.
Good afternoon, ladies and gentlemen. And my name is Chung-Ray Zhu, and I'm from National Science and Technology Center for Disaster Reduction. And it is my great honor to have a presentation, especially in front of you, and it's my great honor. And these three persons, they are my colleagues, and we are working in the Slopeland and Hydrology Division. So today I want to introduce the application of transdisciplinary techniques on slope disaster monitoring in Taiwan. In the beginning, I want to leave a message to you because I'm a technical guy. So I'm trying my best to avoid some technical terms. Yeah, just to give you a very brief and introduction. Just only focus on the application of each techniques on the slope disaster monitoring. Okay. First of all, I want to give you a short video about real landslides happening, so you can imagine how dangerous about this. Yeah, it is. This landslide happens in 2 years ago in Hsinchu, and it's a mountainous area. So you can see there are some students evacuates from the schools, and the local people take the videos. to let us know. And there is a dam lake just formed right there, and it's you can imagine that in this environment is very dangerous. And this is landslide, and this is the dam lake, and here is the village. However, this is a very special case because in the most cases, we cannot take the video so clearly like this. So this is why we need to have the field investigation and doing some monitoring. In traditional way, I think it's a very important work for people awareness, not only for local people, but also for people in charge of the disaster reduction. So here in our imagination, we can choose a very dangerous slope and put a lot of devices on this slope like this, and including the inclinometer and also the underwater level meter, and also the extensometer like this. And also we can do some coring, take some coring to see the geological conditions, and also see the creeping behavior like this. But this way just can let us know just before sliding, because when the landslide happens, these old devices would be destroyed. Yeah, and we cannot take any monitoring after the landslides. So the second question is how many sites we need to concern? Can we affordable about these devices in every single site? So this is why we need to use the remote sensing technologies. The first one I want to introduce for you is the seismology. Recently seismology becomes a promising way to monitor the slope of disasters. We can use it to remote disasters remotely and continuously. And in some literatures, there are some very successful research in literature. And they monitor the deep sea landslides by national seismic network like this. They use the Taiwanese broadband seismic network to monitor the large scale landslides. But that is only for large scale landslide because it's large. Yeah, so they can generate a very serious vibrations and the seismic wave, obvious seismic waves to detect it. And but to monitor the shallow landslide, rock slides, debris flow, that is a small one. Yeah, just near the village, and maybe there are no there are not any seismic stations can detect this kind of signal. So this we want to use the local network. That is the projects I'm working for. We build up a local network to near field monitoring the seismic waves generated by some shallow landslide. But there are some challenges about this because we need the first one. We need an auto processing technique, and it should be trustworthy and efficient. And the second challenge is a small scale movement generates this seismic wave with a higher frequency. And the third one is a serious one. The local network deployed near village or row where lots of random noises is. So the technical gap is not how to recognize the landslide signal, but how to deal with the noise. So I choose a study site in Luhu landslide. It is in the Miaoli County in the north of Taiwan. And here is the rock slide prone area since the since a significant landslide occurred in 2018. So there are more than 5 times rock slides would happen every day. So I deployed the 4 geophones just across the failure slope and doing some measurements for several years. And there are 4 witnessed rock slides have been recorded in our seismic array. And we can use this type of signals to that our model learn which one is the raw slice. We can see this one. This one is a typical raw slice signal. We can see the spindle shape in the time series and also the triangle shape in the spectrogram. And we can also see the wave attenuation between the different stations. Yeah, that is a typical one for the raw slice. And here is the earthquake. This one is the machine operation or reconstruction. And this one is a car just drive past, go through our stations. So we can see there are more types of the noises like farming, piping, villager activity, wind, rainfall, or even thunders would generate a lot of noises in our recordings. So the first thing I need to deal with is how to pick up the noises. So I built up an automatic monitoring algorithm. So there are 3 steps in our algorithm. The first one is detection, just detection the events, just only events. And the other one is noise elimination. I call it the denoise process. And the third one is the classification. All I want to do is to create a very clear database for our model to for learning. We can see the difference. Here is the noise influence database. You can see there are 82% in our data, the noises in our database. And we can see the diverse noise dominates the sample pool so that the machine learning model get lower sensitivity to rock slide and the earthquake. So it's a fail one. And this is a successful one. There's a noise-free database because when I go through my path to for the noising process, and the performance of machine learning model is enhanced significantly because the noise decreased to only 2%. Yeah, so this model can give us confidence to say that maybe someday the IoT-based seismic sensor is possible in the future. And we can use this way to catch the occurrence time of the slope value. All right, that's about the occurrence time. And how about the process? The progress of the landslides, we can use the aero photography, and some approach from the hydraulics can help us to deal with this, to make more things more clear. And we all know that the drone is getting more popular in various applications. Yeah, so for example, like filming, recreation, even for military usage. And that can give us a broader point of view in geographic feature. So we can do some survey with a high resolution and efficient operation. And here I want to introduce the other approach called PIV, the particle image velocimetry. Yeah, that is a common approach. Yeah, we all know that is a common approach in hydraulic experiments. We put some colorful particles into our water tank and to see the water flow and how's going on. And we can use this method to see the deformation of our slope surface. Here is our methodology. We can capture some also photos from our drone and then identify the appropriate markers on the ground surface as our reference points like this. We can mark some very white color and very obvious targets for us to be the reference points, and then obtain the coordinates of the reference points by high resolution GNSS. And the final one is create the whole map, the also mosaic whole map and the DSM for us with high resolution coordinates position. And we can do this job. PIV can estimate the pixel velocity by each also mosaic pair. Yeah, we can see like this, and we can compare the stretch series corresponded with the in situ extensometer data from these points, and we can see these two curves is almost matched. So I think this method is trustable. And also, PIV provides a spatial evolution of the landslides. We can, especially for the location, we cannot put any devices right here, here, and the other locations. And we can see the how it's going of this slope. And also, the time lapse of the also photos is more perceptible for observations. So we can use this way to see the whole procedure of the landslide. The third part is the survey history of the large scale landslides. Let's go back to our to my questions mentioned before. How many sites we need to concern? And our government used the airborne LiDAR and to do the general survey and to recognize more than 10,000 places of a large scale landslide potential area, just right here. We cannot put so many devices on these sites. So we identify more than 200 places containing protected targets with medium to high risk area. And then officially select 34 places. And this year, this number is increased to 48 places. And how can we do that? We use INSAR. So space geodesy can help us. And the tool we use is the Sentinel satellites. It is the radar satellites. And why we use this? Because the repeat cycle is enough, short enough. Yeah, just for 6 days, we'll come back again. And the C-band radar is enough for us to recognize the deformation of surface. All right, here is I want to introduce the PS pixel. The total name is the persistent scatterers pixel. The main idea is that we want to find a stable and stable and strong reflective objects from the surface, like this, buildings, rocks, ridges. Yeah, we can imagine that is stable, right? So when the radar wave just incidents into this kind of pixels, they would reflect, a strong reflects and received by our satellites. So from such a strong scatterers, the surface information signal can be extracted from the background noise like this. We can get a very stable reflectors wave, yeah, from here. And we can compare these images and to create the interferograms and select the PS pixels to trace the PS pixels and the moving of the PS pixels. And the final result is the velocity field map, like this. This is formed by each PS pixels on the map. And also we can trace each PS pixels to create the displacement time series. All right, this is the activity of the large scale landslides. And we can see there are a lot of PS pixels right here. And we can see the velocity of the moving of these PS pixels. And then we can create the time series of each the selected PS pixels from each site. And we can see how's going on and the moving velocities. All right, the next part, because my time is end, so there's a case study. We put these three together. Here is the PS INSAR results. We can see the time series, and this is the landslide in Huhulun in the new Taipei city last year. So we can see this part is obvious drop downs from these results, and also we can see the seismic wave reported by Wufenshan broadband stations, just maybe 10 kilometers. Okay, and here is the also photos and the LiDAR scanning results. There's an interesting part. Here is the landslide area, and we can find out some the other structures. These ancient structures, yeah, is hidden in the forest, so can be discovered in the EM. All right, that is my conclusions. Yeah, satellites, seismologies, and aerophotographies can help us to do a lot of things. So I think the most important thing is studying cross-discipline can give us the different points of view and the new ideas for reference to puzzle out the whole story of our main work. So that's all I have. Thank you very much.
Thank you, Dr. Chu. That's also he's associate professor from Tohoku University, Japan. He will share with us with a very long topic over here. Oh, not yet. Yes, he will share with us through the focusing on the frequency of statements publication from the UN global platform, and to see what's the future of the disaster reduction. No, it's a very long topic. Sure. So, Dr.
Like I said, good afternoon, everybody. My name is Daisuke Sasaki. I'm an associate professor. Okay, thank you so much. What is sound? Okay. I'm an associate professor at the International Research Institute of Disaster Science, IRIDIS, Tohoku University. It's my great honor to give a presentation here at the TC-21 seminar. The title of the presentation is very long. Let me introduce how does the central government make a remark in the international arena of disaster risk reduction, focusing on the frequency of statement publication at the UN Global Platform for Disaster Risk Reduction. Okay, so this topic is a social science topic or political science rather than engineering. Okay, so let me start. Okay, so disaster risk reduction, DRR, has a history of discussion and action in the United Nations. At the third UN World Conference on Disaster Risk Reduction held in March 2015 in Sendai City, Japan, 187 UN member states adopted a new framework called the Sendai Framework for Disaster Risk Reduction 2015 to 2030. All member states are obligated to achieve the 7 global targets described the figure left-hand side. We have the 7 global targets in the Sendai Framework. And this framework was created as a successor to the Hyogo Framework for Action. Unlike the previous frameworks, the Sendai Framework was the first international framework in the field of disaster risk reduction to set specific numerical targets. The Sendai Framework is important not only for the disaster risk reduction field, but also for every field in the 2030 agenda. This progress is reflected in some targets and indicators of the Sustainable Development Goals, SDGs, established in the same year, in 2015. The global platform for the disaster risk reaction, called the GPDRR, is a multi-stakeholder forum established by the UN General Assembly to review progress and share knowledge on ways to reduce disaster risk. It is organized and convened every 2 years by the UN Office for DRR, Disaster Risk Reduction. The main attendees are national policymakers, practitioners, and other stakeholders meeting to exchange their experiences in disaster risk reduction and access information on how other member states addressed particular challenges in the implementation of the Sendai Framework. Thus, the UN General Assembly recognizes the GPDRR as a critical mechanism for reviewing progress in implementing the Sendai Framework. So through this platform, governments, various UN departments, and all stakeholders collaborate to identify ways to further accelerate the implementation of the Sendai framework. Since 2015, the GPDR has been held in Mexico, Switzerland, and Indonesia in 2017, 2019, and 2022, respectively. Okay, so the objectives of the study were as follows. To reassess each member state's attitudes, which are not necessarily noted, but by analyzing the change in the frequency of the official statements published in the global platform for DRR over the last 5 years, from 2017 to 2022. And the second one is to compare the status of official statements with the actual geographical distribution of disaster risks and examine the nature of discussions in the international arena. Okay. And okay, so, oops, sorry. Okay, so the methodology of the study was written here. So the first one is aggregation and visualization of the official statement publication status by member states. A dedicated website was launched at each meeting of the GPDR. The official statements presented by each member state were posted on websites for viewing. In this study, we browsed each meeting website for 2017, 2019, and 2022 and tabulated the number member states whose official statements were posted. In addition, the number of presentations by member states at 3 meetings was represented on a map using a GIS to understand the regional characteristics. And we grasped the distribution area of the hazard magnitude, mortality risk, and economic loss risk of disaster types, such as floods, landslides, typhoons and hurricanes, earthquakes, and volcanic eruptions, using global natural disaster hotspot data. These were obtained from the NASA Socioeconomic Data Application Center, SCDSC website. This open data developed by Columbia University Center for Hazards and Risk Research, the International Bank for Reconstruction and Development, and Columbia University Center for International Earth Science Information Network. In particular, 2 raster datasets were used in the study. One is the Global Multi-Hazard Total Economic Loss Risk Deciles, and the second one is Global Multi-Hazard Mortality Risks in Distribution. Both data sets were reclassified as no data, low risk, medium risk, and high risk, according to the recommendation, and then overlaid to attempt mapping for each combination type in GIS. When assessing disaster risk, we also reviewed spatial information on each hazard scale and disaster risk, as well as the future impact of climate change on food and agricultural production published by the World Bank. Furthermore, we examined the spatial relationship between the official statement publications and disaster risks and issues they suggest. Okay, so the results in discussion. The total number of official statements in the last 3 GPDR meetings of 2017, 2019, and 2022 was 106, 94, and 52, representatively. You know, the percentages of these publication numbers with respect to all UN member states plus Palestine equivalent policy are 54%, 48%, and 27%, respectively. An aggregation and comparison of the previous 3 meetings situations revealed a conspicuous downward trend in the number of member states in issuing official statements. Additionally, 40 member states published official statements at all 3 meetings, while 67 member states have never published official statements. This implies that the GPDR is not necessarily aware of the situations and opinions of all member states. Okay, as shown in this figure, A comparison by continent shows that Asia, yeah, this one, Asia, including the Middle East and Central Asia, has the highest percentage of the member states that published official statements at 3 times. Here, 3 times. And only Asia had more than 30% of member states issuing official statements in all 3 meetings. Asia was also the only continent where the percentage of the member states that had never published an official statement was the lowest, less than 25%. The percentage of the member states that had never published official statements was similarly low in the Pacific region, with approximately 73% of member states having published at least one official statement. And meanwhile, more than 40% of the European member states had never published an official statement before. Okay, this figure 4, shows the number of the published official statements by member states. The Asian region had the largest number. The Asian region had the largest number of member states issuing official statements at a high frequency. Moreover, not only Japan, the People's Republic of China and the Republic of Korea, which published all 3 times in East Asia, but also many other member states in Southeast Asia, South Asia, Central Asia, and the Middle East, have published official statements more than twice. In the Pacific region, only Australia and New Zealand published official statements in all 3 times, all 3 meetings. However, other island member states, other island member states were also active, with Fiji, Kiribati, the Marshall Islands, the Solomon Islands, and Vanuatu issuing them once. A characteristic of America is the high frequency of presentations by member states in North America and the Pacific coast of South America. In contrast, most of the Caribbean member states did not issue official statements indicating a considerable difference with the Pacific Islands, as you know here. So Africa shows no clear trend in the distribution of the member states, with a high number of published official statements and those with a low number of published official statements. However, a few member states in the East Africa, such as Ethiopia, Madagascar, South Sudan, and Tanzania, have published numerous official statements. In Europe, member states with a few published official statements are concentrated in Eastern and Southern Europe. While Norway, Sweden, and Finland published official statements every time, none of the Eastern European member states published all 3 times. And also Baltic states have never published official statements before. So taking another regional view of Europe and Africa, many Mediterranean member states have published no official statements or only a few. So this study also discusses the relationships between the distribution area of the number of published official statements and the overall disaster risk by country, as shown here in this figure. The general trend is that many of the member states publishing official statements face a high risk of natural hazards. Examples include the Pacific coast of the South America, Indonesia, Japan, Mexico, Nepal, New Zealand, and Turkey, which is at high risk for large earthquakes and tsunamis caused by plate boundaries, Madagascar with high economic and human risks of multi hazard shown in its figure. And also Bangladesh and the Philippines, which are affected by tropical cyclones, the seasonal monsoons. Asia has many plate boundaries, Eurasian, Arabian, Indian, Pacific, Australian, and the Philippine Sea, North America, and some microplates, and diverse climate environments. South to East Asia is at risk of heavy rainfall by summer monsoons and typhoons, while West Asia and inland areas are high risk of drought. because of the dry climate. In addition, Japan has been providing the largest amount of international aid to the world in the field of DR. The amount of the Japanese aid surpasses that of the World Bank, and in particular, Japan has long been committed to the assisting Eastern, Southeast, and South Asian member states. When we look at the total monetary aids for DR in the world, excluding multilateral development banks, Japanese aid accounts for 64% of the total financing for DR in the world. It is estimated that the percentage would be greater if the focus were on only Asia. Thus, high DR funding by Japan in Asia may explain why Asian member states are actively participating and expressing their opinions in GPDR. On the other hand, on the one hand, it is interesting to note that the trend between the frequency of official statement publication and the actual degree of risk is not always of one accord. This highlights the reality that the situation and opinions of high-risk regions are not always shared in GPDR. Examples include the Sahel and Sub-Saharan African member states, which are considered to be at high risk of human mortality, as well as the Caribbean and Eastern European member states, which are relatively high risk of economic loss. Okay, so the summary of the relationship between the frequency of official statements publication and disaster risk by region as shown in this table. An important aspect of this matrix is that it clearly shows that the frequency of official statements and is low in some high or medium multi-disaster risk country regions such as the Caribbean. Described here. In Caribbean islands, disaster risk, multi-disaster risk are relatively high, but they rarely published official statement before in the GPDR. Okay, so let me conclude this presentation. So aggregating and comparing the previous the three meeting situations revealed a conspicuous downward trend in the number of member states publishing official statements from the 2017 to 2022. 40 member states published official statements at all three meetings, while 67 member states have never published official statements before. Thus, the international arena in disaster risk reduction is not necessarily aware of the situation and opinions of all member states. And the trends between the frequency of official statement publication and the actual amount of risk are not always closely related. The member states in the Asian and Pacific Ocean region were more active in presenting official statements than those of other countries. In other words, the attitudes of the Caribbean, Eastern Europe, and the Mediterranean, and some sub-Saharan African member states were shared less frequently in the international arena. So many member states in these less frequently published regions also have higher disaster risks. And some least developed member states are actively making official statements and expressing their intentions despite the limited human and financial resources. This fact may be helpful for member states that have not yet made official statements before in the past three GPDR to advance their attitudes and situations in the international arena. So thank you so much for your kind attention.
Professor Sasaki. So in this afternoon, we already seen a presentation from social scientists, Mikio Ishiwatari. He's from JICA, the Japan International Cooperation Agency, and also is a visitor professor in University of Tokyo. And also he is the co-chair of our TC-21 committee. So Dr. Ishiwatari, the floor is yours.
Yeah, thank you very much. Thank you very much for coming, joining this session. I'm as a co-chair of this TC-21. I would express my thanks to all participants. Yeah, my topic is financing. Also, I'm an engineer, but my interest is also covering this financing issue. As everybody knows, investment is very crucial. But not so many researchers or not so many agencies are covering this topic. So I would try to discuss financing from transdisciplinary perspective. Okay, so how we can achieve disaster resilient cities? This is my topic. Of course, financing is necessary. And some people may misunderstand it's a government job, but actually not. Private or resident or communities or local government should cover also. In Japan, as Katsuhama-san already explained in 1995, Kobe earthquake happened. Oh, yeah. Okay. So in 1995, Kobe earthquake happened, and we Japanese noticed such a density populated area, urban area is very vulnerable against disaster. We lost over 6,000 people in Kobe. And so my topic covers two parts. First one, before disaster, how to create disaster resilient city. Secondly, how to rehabilitate uh, disaster resilient urban areas after disaster. I will cover these two areas. Okay. Okay, so first one, before disaster. How we can improve such a dense residential area? Yeah, this is we learned from the Kobe earthquake. If housing collapsed, more fire occurs. So one research says fire occurring ratio became triple when buildings collapse. And of course, collapsed buildings block roads, and the firefighting or rescue or evacuation become difficult. So it's of course need to build a disaster resilient town. So this is some Japanese, actually Tokyo area downtown. There are many such housing areas. Maybe against your image, but still there are many. Because of many people came from rural area to Tokyo downtown to look for jobs. Yeah, I know in some developing countries currently ongoing, and we've experienced such things in 1950s or 60s. It's very convenient. It's in downtown, so it's very convenient for job or daily life. However, already some decades passed, so these areas are aging and decreasing population, and the infrastructure is not well developed, and aging and low quality houses remain. So how to improve? This is a issue. So this is a Tokyo area, and this red areas are such a dense wooden housing area. It's a risky areas. So following the Kobe earthquake, Japan, we enacted some law to improve such a low quality, dense wooden housing areas. And this law supports voluntary efforts by landowners, residents. Yeah, so this is an image. So landowners can choose if they want to live in the same district in individual houses or they want to move to apartment, they can choose. Or if they want to move outside, it's all right. It's also okay. And they don't need to pay because they have land rights. So land rights can be changed to new houses landlords or new apartment floor. So this is some mechanism. So it's like this one. So such a bad, poor quality houses change to such a new building, so new apartment in this case. And the road is widened. It's good for preventing fire spreading or good for firefighting and for evacuation. And park, it's also good. And underground, quite often they construct tanks for emergency water supply. So how the cost sharing? National government and local government cover 1/3, some 30% of total cost. And yeah, because they construct new buildings, they can get some revenue, some 60% covers. And the residents, they don't need to pay. It's a changing rights. And quite often involving private sector because some company can expect some profits selling apartments or selling houses. and of course, private sector has some knowledge or skills to develop. So we can use such as their know-how of development. However, some issues, consensus building, as I said, it's aging. So many elderly live. And quite often they don't want to reconstruct or they don't want to move. If someone, even one person, they don't agree this plan, nothing happens. So, so this is a quite crucial issue. And the period, usually it takes 10 years average, and 3 years for construction. So for private company, 3 years a very crucial period. So how to shorten or how to predict or how to see how many years they need. This is another crucial issue. So what the government did is flexible schemes. They are combining various schemes. We have a land pooling schemes or development schemes. I don't want to explain details. I don't have time, but combining some several approaches. And secondly, if one person, he or she don't agree, yeah, the planning area can be modified and excluded one person, and other areas will be developed. So yeah, in some case, only one old house remains, and the next beautiful buildings constructed. Such things happen. But anyway, it's a very flexible. And further issues, social welfare, because they are aging, they are elderly. So how to combine with social welfare? This is some remaining issues. Okay, so next one is the reconstructing towns. Yeah, this morning Korean case explained dam water release. After dam water release, flooding happened and the government compensated. Yes, it may happen. So some question is not case for Korea, as a general question. Is it fair to support people affected large-scale disaster? Yeah, for example, we may have some traffic accidents or we may have some fire or something, any disaster happened. But if we cover warmly for natural disaster, is it fair socially? Second question is, should government support to create private assets? Housing is a private asset. Should government do such things? These are some questions. Of course, there are many other questions. And this is a case of Japan. Yeah, Japanese government or mass media, we've discussed such things very long time. So gradually, government support for reconstruction housing increased. At the Kobe earthquake, no central government supported. Only local government, Kobe City, provided some 1 million yen or something. After that, Tottori earthquake, 3 million. This time, national government started financial support for the construction. And as the Kobe earthquake, as the Tohoku tsunami, yeah, local government supported 2 million or 10 million, 10 million yen, in addition to central government 3 million support. So as such, in Japan, such a financial support is expanding. Okay. Yeah, yeah. So this is sort of a Tottori earthquake with a sort of a critical time. At that time, prefecture governor decided to support victims to construct houses because it's a rural area. If they don't have financial support, everyone will leave and community will collapse. That's why governor decided to start providing financial support. And the national government says 3 million support. They say it's not compensate, just support for their lives. If they say compensate, it means creating their asset, personal asset. They wanted to avoid. So this is a tsunami recovery plan. Yeah, thank you very much for Taiwanese people. We know we've received lots of support from Taiwanese. Yeah, anyway, this is some relocation program. Prohibited construction houses in lowland area, tsunami area, and constructing housing in higher ground. This is complicated. Some 350,000 houses were reconstructed. And first one is reconstruction sites, not housing. How much they spent? It's 61 million Japanese yen, some over 400,000 US dollars for one lot, not including housing construction. It's a huge money actually. And yeah. And average construction cost, in addition, of course, each victim, each affected people construct houses by themselves. Average cost is 25 million Japanese yen. And the public assistance, in this case, in total, 15 million Japanese yen someone could receive. It's a huge money again. It's a sort of a competition among local government. Because young generation, in particular, young generation, they wanted to move to big city, like a Sendai. And yeah, because it's a good job, a good education. So if original town wants to attract affected people, they have to compensate, they have to support financially more. So it's a sort of competition among local governments. And the public apartment is provided for some vulnerable families like a low income people or elderly. They cannot afford to reconstruct houses by themselves. That's why local government provided public apartment as they live here. Okay, so some consideration and conclusion. So Japanese government stance is very consistent and clear. Housing is a private asset. That's why residents should cover housing construction by themselves in principle, or how to reconstruct by themselves. They can construct by themselves and they can pay insurance. They can pay a premium for insurance. And the government not financing, creating personal assets, not compensating. And financial support is provided, but for rehabilitating local communities or their lives, daily lives. That's the purpose. However, as I explained, there is no clear criteria, how much government cover or how much people cover. Yeah, in case of Kobe earthquake, central government, nothing. But at the tsunami earthquake, yeah, in some municipality, half of money can covered by government. So there is no such a theoretical ratio or something. It's always some political issue or some such a societal issues. Okay, almost time. So so this is some lessons. So national government support is essential. Local government can facilitate, and flexible mechanism is essential. And the voluntary efforts by residents, this is another crucial area. And how to engage private sector. This is useful for making city resilient. Okay. Yeah, thank you very much. And I'm considering some further support, further studies. And this is just a Japanese case. So I want to compare some other countries, in particular Taiwan. If you have interest, please do some joint research works. Okay, Tasha, thank you very much.